to the cloud. All right, I'm recording now. All right, so this is, so we are still in section 7.1. Right, so of course it's about normal distribution. All right, guys. So I'm gonna just remind you what's a normal distribution and how to find the probability of a normal distribution. I think we had an exercise from the last week. We didn't have time to finish the exercise, so I'm gonna probably go over the exercise of the last week. But first, I'm gonna just remind you of the idea and how this normal distribution works. Right, so recall. So as I said last week, this normal distribution, this is one of the most important probability distributions. So it's given by a graph, right? So the normal distribution is given by a graph. So normal distribution is given by actually a bell-shaped graph, okay, with highest point at the mean. Now, what do I mean by it's given by a graph? So you're gonna have some graph where the horizontal axis would be your x-axis. So the x, of course, is your variable. For example, in in the binomial distribution, the variable is the number of successes, right? Because the goal was to find the number of successes out of n trials. So your variable was r, the number of successes. So here, this is very general. So your variable is, we call our variable x. So that's your horizontal axis, so you have a bell-shaped graph. So it's gonna look like something like this, right? And we said the highest point of the graph corresponds to the mean. So we denote the mean by mu, right? This is mu. This is mu. This is the mean. Because we denote it by mu because instead of x bar, because this is not a sample mean. This is a population mean. That's why we denote the mean here by mu, and not by x bar. So this is a population mean. Population mean. And so again, this is mu, mu. All right, and the idea is if you want to find the probability of, let's say, you want to find the probability that x is less than some number. So I want to find probability that x is less than, well, before that, just remind you that the area under the graph is supposed to be equal to 1 or 100%, right? So the area, of course, the area under the graph, under the whole graph, okay? So the area under the whole graph is equal to 1. In other words, that's 100%. And percent means, of course, division by 100. So when I say 100%, that's 100 over 100. That's equal to 1. So now the idea is if you have some value, for example, I'm gonna just take some numerical example here. Let's say 5, okay, on your x-axis, and you want to find the probability that x is let's say less than 5. X is less than 5. Okay, this number 5. So then this probability is given by the area to the left of 5. So what we do is, so we take 5, right, and So the probability that x is less than 5, that will be the area to the left of 5. So you take your 5, and the probability is the area to the left of 5, right? So probability that x is less than 5, that's the area to the left of 5. Okay. Of course, the problem is, of course, how do we find such area, right? This area to the left of 5. Okay, but we'll see in a minute in our exercise how do we do that, right? Now, if you have, for example, now when I find the probability that x is larger or more than, x is more than 5, x is more than 5. So when we say more than 5, then we mean the area to the right of 5. So that will be the area to the right of 5. To the right. 5. Okay. So that's the idea. So when I find the probability that x is less than some number, then that will be the area to the left of that number. Probability that x is more than some number, then that will be the area to the right of that number. And of course, the area to the left plus the area to the right of that number, the total is 100%, right? Because that will be the whole area under the graph. So you see the green here, this green here, that's the area to the left of 5, right? That's the area to the left of 5. Now the blue area, this would be the area to the right of 5, right? That's what I mean by the area to the right of 5. So this is the area to the right of 5. Okay. And so of course the area to the left of 5 plus the area to the right of 5, that will be the whole area under the graph, and that's 100%. Then one more thing. So we have this x, probability that x is less than a number. We have probability that x is more than some number. We can also try to find probability that x is between two numbers. So x is between two numbers. Let's say 5 and I don't know, 5 and 10. Okay, so that's 5, and then here somewhere we have 10, right? And you want to find probability that the variable x is between 5 and 10. X is between 5 and 10. So x is between 5 and 10. Then this probability corresponds to the area between 5 and 10. So that will be the area between the two numbers, the area between 5 and 10. Right? So then that will be this, let's say, so this is 10, this is 5. So the area between 5 and 10 would be this one, right? This is the area between 5 and 10. This is the area between 5 and 10. So again, here, guys, the idea is you have the graph of your normal distribution, then the graph, the area under the graph represents some probability, right? So if it's the area to the left of some number, then that will be the probability that x is less than that number, right? Etc. So the area under the graph actually, represent a probability of your x being less than a number, okay, or more than a number, or between two numbers. So so it's really important to know what will be the areas under the graph. So so then last week we said, so when we have a probability distribution, so now, so when we have a normal distribution, then whenever we have a normal distribution, then we have the following areas. then we have the following areas. So the areas between your mean and mean plus or minus some multiple of the standard deviation is actually known. So this is your x, of course, and here's your graph. Again, it's bell-shaped, etc. Here's the center, the highest point. That's the mean. This is the mean, mu, right? And then, of course, the area end of the graph, the whole graph is 100%. Now, if you take the mean plus the standard deviation, sigma. So sigma here denotes the standard deviation. This is sigma, lowercase sigma. Okay, that's your standard deviation. Again, here we are using sigma instead of s because this is a population standard deviation. It's not a sample standard deviation. Anyway, so if you take the area between the mean and the mean plus the standard deviation, that's equal to actually 0.34 or 34%. So this is 34%. Okay, so the area of this region between the mean, mu, and the mean plus sigma is 34%. The other side, if you subtract, if you do the mean minus sigma, right? So this is the mean minus sigma, right? Then again, between the mean minus sigma and the mean, so this area here, it's also 34%. So we have something which is symmetric about the mean. Now, if you take the mean plus 2 sigma, so 2 times sigma, so this is mu plus 2 times sigma, right? Then the area between mean plus 1 sigma and mean plus 2 sigma, so this is mean plus sigma and this is mean plus 2 sigma. So the area between them is actually 13.5%. So this is 13.5%, right? Now the other side, you have the same thing. This is mean minus 2 times sigma. So it's again 13.5%. So again, the area of this, you see this blue region here? The area of this blue region is 13.5%. And when I say 13.5%, percent means division by 100. So 13.5%, that's like 0.135. So the area of that region, this blue region, is actually 0.135. All right, of course, we can continue. So we can have like a mu plus, oops. You can have like mu plus, this is mu plus 3 sigma. Then the area between the mean plus 2 sigma and mean plus 3 sigma is actually 2.35%. So this area here, this yellow area, it's actually 2.35%. The same thing on the other side, between mean minus 3 sigma or 3 standard deviation and the mean minus 2 sigma. So you have again 2.35%, etc. So what we have to keep in mind, guys, is that this graph is symmetric about the mean. So which means that if you start from the mean and you go to the left, then the area to the left of the mean, that's 50%. Now, if you start from the mean and you go to the right, then the area to the right of the mean, that's also 50%. And of course, 50% plus 50%, that's 100%. And that's equal to 1. That's the area under the whole graph, right? And one more thing, guys, you need to keep in mind that the graph, it doesn't really intersect. It doesn't intersect the x-axis. Here, there's no intersection here, right? So the graph is gonna get as close as you want from the x-axis, but it doesn't intersect. There's no intersection between the graph and the horizontal axis, right? So here there is no intersection, no intersection. Okay, so which means that you're supposed to we can continue with our with our areas like after mu minus sigma, you can have like mu minus 4 sigma, etc., etc., right? So here there is no intersection. All right, so this is just to remind you of this whole idea about the normal distribution. And so we had an exercise. So exercise from the textbook. I think it was exercise 7, page 302, right? I think so. Yeah. All right. So what does it say, the exercise? It says the following. So you assume that the heights of the college women are normally distributed with mean. So heights of college women are normally distributed. So when you see in a problem normally distributed or normal distribution, it means that, of course, you're going to use the fact that your distribution is a normal distribution, right? So it's not a binomial distribution. This is a normal distribution, or normally distributed, right? So we have a normal distribution. That's a normal distribution. The variable x, the variable, is going to follow a normal distribution. So of course here we are interested in the heights of the college women. So the variable here is the heights, the height of the college women, right? Anyway, so the heights of the college women are normally distributed with mean. So the average with mean 65 inches. I think it says with 65 inches with mean. So mu equal to 65 inches. So here we don't have a, guys, here we don't have a sample mean. This is not a sample mean. This is the population mean. So this is like the average of all, the average of the heights of all college women, right? It's not a sample. It's not a sample mean. So the mean is 65 inches and the population standard deviation is 2.5, I think, inches. And standard deviation S. Is, sorry, not S, but sigma. It's a population standard deviation, so it's 2.5 inches. Anyway, so just from these informations, guys, we can, because we know it's a normal distribution. It says it's a normally distributed, so we have a normal distribution. So we have a graph, and in our graph we have this bell-shaped. So our graph is bell-shaped, etc. And then the mean will be the highest point. The mean in this problem is 65. So here's my 65. That's my mean, mu, right? And then I can say, for example, if I take the mean minus or mean plus sigma, right? So what's mean plus sigma in this problem? Well, mean plus sigma would be equal to, so the mean, oops, sorry about that. When I use the, yeah. So what's mean plus sigma in this problem? Well, the mean is 65 and sigma, the standard deviation is 2.5. So it's 65 plus 2.5. So that's 67.5, right? So here, this is mean plus or mu plus sigma, that's 67.5, right? And I know because this is a normal distribution, right? Because it says in the problem, it says normal distributed, so it's a normal distribution. I know that the area between the mean, which is 65, and 67.5, I know this is 34%, right? I know this is equal to 34%. Right? Now I can do the same thing on the other side with the mu minus sigma. All right, so it's like 65 minus 2.5. So that's 62.5. So this is 62.5. Right, so on the other side, this is mu minus sigma, which is actually 62.5, right? And I know, because it's a normal distribution, I know that the area of this region is actually 34%. Between the mean, the 65, and the 62.5, the area is actually 34%, etc. You know, you can do the same thing for now for mu plus 2 sigma, right? So next one here would be mu plus 2 sigma. So what's mu plus 2 sigma in this problem? So mu plus 2 times sigma. Mu, my mean is 65, plus 2 times, this is 2 times, right? This is a multiplication. So 2 times sigma, my standard deviation. So it's 2 times 2.5. So that's 65 plus 5, which is 70, right? So mu plus 2 sigma is actually 70 inches. So this is 70 inches. And again, because it's normal distribution, I know that this region here between 67.5 and 70, it's actually equal to 13.5%. This is so this is the 13.5%, etc. Right? So the other side here, that will be mu minus 2 sigma, and that will be 60. If you do 65 minus 2 times 2.5, that will be 60. And again, we're going to get this 13.5%. This region here, that's 13.5%, etc. All right, guys. Now the questions. So this is just, so you have this graph just because, it's a normal distribution and because, the mean and the standard deviation, right? All right, now I want to find some probabilities, right? I want to find, for example, what does it say here? Well, for A, it says, and yeah, before A, just to remind you that, so if you, this is your mean. So if you go from the mean to the left, then the area to the left of the mean, that's 50%. And the area to the right of the mean, that's another 50%. Because the mean divides your graph into 2 equal regions, right? So each region is 50%. Any questions so far, guys, before answering the ABC, etc.? Let me see the chat. Oh, I see some questions, I think. Oh, Yanin, Edward. Okay, thank you, guys. I got you. Thank you. All right. So yeah. So let's answer. Let's see what's A. So A, for example, we said what percentage of women are taller than 65 inches, right? What percentage of women are taller than instead of 60, it says 65 inches. Okay, let's do it. 65 inches. Right. So percentage of women taller than 65 inches, right? So you wanna so again the variable here x represents the height. Okay, so that's your height. Again, x, the variable x, that's when I say x is 65 inches or 67.5 inches or 70 inches, etc. That's the height of the college the college woman, right? So x, the variable x, is supposed to be the height of the college woman. Right. Anyway, so here we want the percentage of women, what percentage of women are taller than 65. So taller than 65 means it's more than 65, right? Taller than 65. Taller than 65. So in other words, that's more than 65 inches, right? So what's the percentage of women taller than 65? More than 65 inches, right? So So we want the probability that x, the height, is more than 65, is more than 65. In other words, x is larger than 65, right? So let me just remind you here, larger, the symbol for larger is, so that would be x larger than 65, right? So this is a symbol for, this means larger, right? This inequality here, this is x larger than, or more than 65, right? So if it's more than 65 or larger than 65, so that will be the area to the, is it to the right or to the left of 65? If it's more than 65. And you guess, guys, if so, if x is more than 65, then that will be the to the right, right? Thank you. So more than, we said more than, that will be the area to the right, right? More than, that's the area to the right. To the right. Okay. So of course, so I need to find this area to the right of 65. So now 65, I know my 65 is the mean, right? So here is my 65, right? This is my 65. So I need to find the area to the right of 65. So the area to the right of 65 would be like, of course, would be, this is my 65 right here. So I need to find the area to the right of 65. So that will be this area here, to the right of 65. Now, what's this area to the right of 65? Any guess? So that would be the area to the right of the mean. And we know that the area to the right of the mean, we said it's always 50%. Whenever you take the mean, then the area to the right of the mean, it's always 50%. Okay? So this area here to the right of the 65 is just 50%. Or 0.50. Okay, so this percentage, so because this is the mean, then the percentage or probability that x is more than 65. So again, this means more than or larger than, larger than 65. The answer is 50%, which is 0.50 if you divide by 100. So the area to the right of 65 is 0.50 or 50%. And that's because it's the area to the right of the mean. It's always 50%. Now, let me change here the question. So what percentage of women are taller than 65? Let's say now I want to find the percentage of women so what percentage of women are taller than, let's say 67.5 inches. Right? So any guess, guys, what will be the percentage of women taller than 65.5 inches? Sorry, 67.5 inches. All right, 67.5. Say again. Sorry.
Would it be 50?
50, that would be taller than 65. Here I'm saying 67.5, right? This is my 67.5. So what will be the percentage or the area to the right of this 67.5? So the area to the right, so the area to the right of the 67.5 would be this one, right? This is the area to the right of 67.5, right? The green one. Right, so this is the area to the right of 65. Right of 67.5. So in other words, that would be the area from this point, right? From this point to the right. So what will be this area here?
25?
Nope, it's not 25. Nope.
It'd be 17.
It's actually 16.
Okay.
That's because you see from okay, let me graph again my probability distribution, because the other one, it's just a mess. So here's my 65, right? And here's my 67.5. Here's my graph, right? This is like my graph. And I'm saying this is because this is the mean, right? So from the mean to the right, from here to the right, that's 50%, right? Now, I want to find the area to the right of 67.5, not to the right of 65, but to the right of 67.5. So I want to find this area here, right? This one, right? That's what I'm trying to find, right? This area to the right of 67.5. Now, the thing is, I know that the area between the 65 and the 67.5, this one here, this is 34%, right? We said this is 34. So, and the thing is, I want to find this area here to the right of 67.5. So the missing, the difference here between the 50, the 50% and the area I want to compute is, this one. It's this one here, right? That's the difference, and that's the 34%. So the difference between 50 and 34, that would be exactly my green, my green region, right? The area of the green region. So the difference between 50 and 34, that will be exactly this area, right? The green one. So yeah, so percentage of women taller than 67.5. So again, this notation here means, so this is more than or larger than, more than 67.5. So that will be the 50%. That's like the percentage to the right of the mean. And I subtract the area between 65 and 67.5, right? This one here, which is 34%. I know it's 34%. So the remaining area would be, so the difference would be 16. That's 16%. So this green, the area of this green region is actually 16%. Does this make sense to you guys? I mean, please let me know if it's too confusing, or do you see why I got the 16? It's because of this 34, and it's because I know that to the right of the 65, it's 50%, right? So then the difference between 50 and the 34, that's exactly my green region, right? So let me just check the chat. All right. Right. So so that's taller than 67.5. Let's say you wanna find now C percentage of women, college women, taller than, not taller, let's say, let's change here. Let's say between percentage of women between let's say 62.5 inches and let's say 67.5 inches. right? Um, so so that will be probability that your x. So between, so notation for, so for more than, we use this symbol, right? This is more than or larger than, right? Now between, we're gonna use this. So so this is 62.5 and 67.5. So your x, so here, this is larger. So x is larger than 62.5, and so your x is less than 67.5. Okay, so this is larger. So here, let me just use, so here, this is x between, right? So let me just write down here. So x is between 62.5 and 67.5. So your x is, so this is to say that x is larger than 62.5, okay? And here, this is to say that x is, your x is less than 67.5. So it's between 62.
Why is not working?
Say again, sorry. Yeah, so between 62 and 0.5 and 67.5, of course, we're gonna use our graph. There's this 65 here, there's your 67.5 here, there's this 62.5. So here's your graph.
Is it
And
34?
again, not exactly 34. Between, so between 65 and 67, that's 34. And you have another 34 between 62.5 and 65, right? So now between 62.5 and 67.5, it's not just 34, but it's 2 times 34, right? That's twice 34. Okay, so it's gonna be exactly this region right here, this one here. All right, so it's 2 times 34. So it's 30. So it's, so x between, sorry. So 62.5 and 67.5. So that would be 34. So that would be equal to 34% plus, so let's say this 34 here, right? And another 34 here, plus another 34. So the answer would be 68%. That would be the percentage of women between 62.5 and 67.5 inches. All right. You see, guys, why it's not just 34, it's actually 68, right? Because it's not just one 34, we have 2 34 here, from 62.5 to 67.5. What else? Yeah, we can have less than. Let's do another one. Is there any question, guys, so far? So again, the idea here is to play with the areas, right? So you need to just be careful with the words when it says like more than, so that's the area to the right, and less than, that will be the area to the left. But yeah, let's do an example of the area to the left. So for example, let's say you want to find the percentage. So what percentage of college women, what percentage of college women, etc. Let's say shorter than 62.5, let's say, for example, inches. Okay. So here, of course, shorter than 62.5, it means less than, right? That's less than 62.5 inches. So your height is less than, the height X is less than 62.5 inches, right? So we want to find the probability that the height X, that's your variable that represents the height, is less than. So this is, X is less than 62.5. So this symbol here means less than. This is less than. Yeah, guys, just again, the difference. So this one here, this is larger than. And then the other way, that will be less. This is less than. This is less than. So here your X is less than 62.5. All right, so let me graph again. My normal distribution, etc. This is your 65 right here. There's this 62.5. This is, we said this is 34%. This is 67.5, and that's 34%, etc. And yeah, and from here, from to the left of the mean, that's a 50%, and to the right of the mean, that's the other 50%. All right, guys, any guess what will be the area to the left, right? Less than, so that will be the area to the left of 62.5. So this is less than 62.5. So this is the area to the left. To the left of 62.5. So the area to the left, of course, of 62.5 would be this one here, this green region.
Would it be 16%?
Yes, would be 16, right? You mean 16, right?
Yes.
Yeah, 16, because how did you get the 16?
I did the 50% minus the 34.
Yeah, yeah, absolutely. Yeah, that's correct. Yeah, very good. So yeah, just again, the idea is the same, right? Just the whole area to the left of the 65, that's 50, and then if you subtract the 34, you know, this area right here, if you subtract this 34, then you get exactly what we want, right? So yeah, it's just 50 minus 50% minus 34%. So again, it's going to be 16%. Right? So anyway, so any question, guys? So what we need to keep in mind, what's really important for the next section is the following. So we need to understand that you know, when we say the area to the left, so probably that X is less than some number, for example, 62.5. So this is the area to the left. So this is less than. So that will be the area to the left of 62.5. So when I say probably that X is larger or more than 62.5, so this is larger than or more than 62.5. So that will be the area to the right of 62.5. To the right of 62.5. All right, and of course there is the area between two numbers, right? We have like let's say your X is between I don't know, let's say 60 and 65. So this is X between two numbers, right? This is the area between two numbers, area between, you know, the 60 and the 65. Okay, so we have like three different cases. So like whenever you have a problem about normal distribution, so it's gonna be just one of these three cases, right? So either it's gonna be the area to the left, that's less than, or the area to the right, that's when you have like larger than some number, or you're gonna have like area between two numbers, right? Do we do another exercise, or we can probably move to the next section? Let's see. I think yeah, I think with the last week we did at least two examples or two exercises. Yeah, I think we can probably move to the next. I mean, the next section is just of course, it's a continuation of this normal distribution. All right. Let me see if there's any question in the chat. All right. So next. Well, so I'm going to use the same example, this example where, so X represents the height of the college woman. And so we have, again, this is your mean right here, 65 we said. Here we said this is a 67.5. This is a mu plus sigma. You know, this is, we said it's a 67.5. This is mu minus sigma, mean minus standard deviation. This is 62.5, right, etc. And we know this is 34%. And we know this is also 34%, etc. Right? We have next we have like you know, mean minus 2 sigma, and here like mean plus 2 sigma, etc. Anyway, now if for example I want to find the percentage of women taller than 66 inches. Okay. So taller than 66 inches. So that will be the area to the right. Taller, of course, taller than 66. That's more than 66. So that will be the area to the right of 66, right? So again, let me just write down here. So taller than 66. That's more than 66. So that's the area to the right of 66. Now, for notation, so that would be probability that the height x, or probably that x, the height is more than, so it's larger than, so so it's x larger than 66, right? This is a symbol for larger than, or more than, right? Anyway, so now where is my 66 inches? Well, of course, it's going to be, you know, between, I guess, somewhere between, you know, 65 and 67.5. So let's say this is my 66, right, inches. Now the question, of course, is, you know, how can we find? So I need to find the area to the right of 66. So that'll be this area right here. To the right of 66 is this one here, right? So here I am you know, we have a problem here because I don't have any information about the 66, right? The 66 inches, right? I mean, I have information about, you know, the 65 because that's like the mean. I know like the area between the 65 and 67.5, that's 34%. Or for example, I know the area to the right of 65, etc. But I don't have any information about 66, right? I have information about 65, 67.5 because that's my mean plus sigma. I have information about my you know, 62.5 because that's like my mean minus sigma, etc. Right? But there is nothing about the 66. Okay, so we are kind of a trouble here. So how can we find the area to the right of the 66, right? So here we have a problem. Well, of course, we're going to try to solve this problem. in the next section. So here, this is a problem because so we don't have any information about the 66, right? Information about the 66 inches, right? Because I know like my mean is 65. I know like if I do mean plus sigma is 67.5, you know, my mean minus sigma, it's 62.5, etc. But I don't have this 66, right? I cannot really express this 66 in terms of the mean and the standard deviation, right? So then, so the question is, of course, is how do we find the area for a random value of x? That's the problem. So how do we find the area to the left, for example? So the areas to the left or to the right or between to the left or to the right, or between random values of x. Random values of x. Okay. Because again, this 66, it's not my mean. It's not my mean plus standard deviation. It's not my mean minus the standard deviation, right? So I don't have any information about the area between this 66 and the other values, right? So yeah, so to answer this question, we're gonna move to the next section. Okay, so so section 7.2. So we're gonna do 7.2. We're gonna do the standard normal distribution. Standard normal distribution. So in this, so there is this word standard, right? Normal distribution. All right. So the thing is, we're gonna use the sum table from the formula sheet to find, you know, the areas to the left or to the right or between, you know, some random values of x. But before that, so we need first to understand what's this standard normal distribution. So a standard normal distribution, of course, it's a normal distribution. So again, we have the same graph with the same numbers, same areas, you know, between the mean and mean plus sigma and mean plus or minus sigma, etc. So the standard normal distribution, it's a normal distribution. Standard normal distribution is a normal distribution okay, so it has the same properties as the normal distribution, bell-shaped graph with the center, with the highest point at the mean, etc., etc. But the thing is, with the mean in a normal distribution, a standard normal distribution, the mean is equal to 0 with mean. So mu is equal to 0. So in a standard normal distribution, the mean is 0 and the standard deviation equal to 1. And standard deviation sigma so sigma is equal to 1. And the variable of the standard deviation, instead of using x, we're going to use the variable z. Okay, it's just a notation. So we denote the variable. We denote the variable of the standard normal distribution. The standard, again, it means that the mean is 0 and standard deviation is equal to 1. So of the standard normal distribution by z. Instead of X, we're gonna use Z. You'll see later why we change X to Z. So with the Z, the variable Z. Sorry, we denote by the variable Z. The variable of the normal standard normal distribution by the variable Z. All right, so why do we bother ourselves with the standard normal distribution? The thing is, and which is the good news, is that we have a table in our formula sheet that we can use to find the area to the left of any random value of Z. So the good news here, and the thing about the standard normal distribution is that we can use the table. There's the table number 3. I'm gonna show you in a minute the table. So we can use table number 3 in the formula sheet. To find the area to the left, to find the area to the left. So it's only the area to the left given by the table 3. The area to the left of Z. Any Z, okay, any value of Z. For example, let's say you want to find the probability that, so example, and I'm going to show you, of course, how to use the table to find the percentages or the probabilities. So for example, first example 1, let's say you want to find probability that Z is less than let's say negative 1 point let's say 0.8. So this is less than, right? Less than. So less than, that's the area to the left. Area to the left. So here what I'm saying is, so we have this normal, this standard normal distribution. So instead of the variable Z, instead of the variable X, we have the variable Z. And so it's a normal distribution again, right? Etc. Now the mean of the standard normal distribution, the mean is going to be 0. Okay. And of course here there is, and the standard deviation is 1, right? The mean is 0 and the standard deviation sigma is 1. So like if you do mean plus 1 sigma, so that will be 1. If you, this is a mean plus sigma. If you do mean plus 2 sigma, right, that will be 2. So this is, that will be 2 here, right? So if you do mean plus sigma, that's 0 plus 1, that's equal to 1. If you do mean plus 2 sigma, you know, that's 0 plus 2 times 1. So that's equal to 2, etc. So for example, of course, we know that the area between the mean and the mean plus sigma, this is supposed to be 34%, right? This is supposed to be 34%. Between mean plus sigma and mean plus 2 sigma, this is, we said this 13.5%. The other side, we have mean minus sigma, because it's a standard normal distribution, then the mean is 0, sigma is 1. So if you do 0 minus 1, that would be -1. So this is like -1 here. All right, this is -1, and it's just erase this here. So this is -1. All right, that's my mean minus sigma, and I know this is like 34%, right? And here, if I do mean minus 2 sigma, that's 0 minus 2, that's -2. And I know the area of this region here, this is 13.5%, etc. But the thing is, here I want to find the area. So this is Z less than. So that's the area to the left of negative 1.08. So negative 1.08. It's it's somewhere between -1 and -2, right? So the negative here is my negative 1.08, right? It's not -1, it's not -2, so it's between -1 and -2, right? And I want to find the area to the left of this negative 1.08, right? So this is like kind of like a random value of your variable. It's not, it's not -1 or it's not -2. So I cannot use the, the 34% or the 13.5% or, the 50%, etc. So this is kind of like a random value, right, of the variable. So I cannot use this 34, the 13.5%, etc. So what I'm supposed to do in this case? Well, the thing is, we can use, so what I'm saying here, guys, is that, so I want to find the area to the left of, so this is equal to negative 1.08, right? So how we're going to use, so this table 3 from the formula sheet. All right, so let me share with you the table, guys. So again, keep in mind, so our Z is negative 1.08, right? So before using the table, let me just say here that the negative, so Z is negative 1.08, right? So then the nearest tenth to the Z, we're gonna need the nearest tenth and the nearest hundredth. So we need to use the table. I'm gonna show you in a minute how to use the table, but to use the table, we need the nearest tenth of Z and the nearest hundredth of Z. Hundredth of Z. And nearest tenth of Z. So of course, the nearest tenth of Z is just the, the digit after the decimal point. So the nearest tenth would be just this, right? This is the tenth, and this is the position of the tenth. This is the position of your hundredth decimal, right? So nearest tenth of Z is negative 1.0. And the nearest hundredth is the 8, right? The 0.08. So nearest hundredth is the 0.08. Okay. Now let's go to this table 3. Let me show you the table right here. All right, there is a table 2, right? This is the table 2 to find the binomial distribution. So now we need to go to the table 3. Table 2, and yeah. So here is the table 3. Okay. So you can find this table again, guys, on its own CUNY. I mean, there's the formula sheet. It's on CUNY Blackboard. If you go to the CUNY Blackboard, I guess. I think the formula sheet is there. If you just go to the course, if you go to the course content, then you can find the formula sheet. All right. Now, so you see the first column. So the first column, that's the nearest tenth of the Z. So like in our case, the nearest tenth of of our Z is negative. Our Z was negative 1.08, right? So the nearest tenth, it's negative 1.0. So the first column, you need to go to negative 1.0. You see the first column? So you go down, it starts with negative 3.4, right? But then you have negative 3.3, negative 3.2, etc. Negative 3.0, negative 2. 9, but in our case, in our example, we need to go to negative 1.0. That's the nearest 10th, right? So here is, so you can see here, if you go down, you know, after a negative 3.4, negative 3.3, etc., you go all the way down to negative 1.0. Okay, that's your nearest 10th. Now, you see the row of negative 1.0. So we have like 0.1587, 0.1562, 0.1539, etc. So if you check the top, like the first row in the top, you have like 0.00. The first row in the top, you have 0.01, you have 0.02, etc. Our nearest hundredth, it's 0.08, right? So we need to go, so the corresponding value, or the corresponding answer in this case, right? So 0.08, you're gonna get, if your nearest 10th is negative 1.0, the answer would be 14.01. Okay. So let me explain again here with the board. So what I'm saying, guys, is the following. So you have your z. This is the table phi, right? This is our table phi. So it starts with a negative 3.4. There's like a negative 3.3, right, etc. So in our case, because z is negative 1.08, right? So we said the nearest 10th, that's the first the digit after a decimal point, right? That's a 0, this one here, right? So negative 1.0. So we need to go all the way down to negative 1.0. Okay. Now, in the row negative 1.0 here, right? If you check the top, the first row, we have like, you have your z, and then you have like 0.00, 0.01, you have like 0.02, etc. But in our case, the nearest hundredth, so the top, that's your nearest hundredth. So the hundredth here, it's the 0.8, right? That's your hundredth here, right? It's a 0.08. So we need to go to 0.08. So then the answer would be this number right here, in the row of a negative 1.0, the column, it's 0.08. So the answer, as we said, it's, you know, negative 1.0. You need to go all the way to 0.08. So that's 0.1401, right? So you have 14. Have here 0.1401. Okay. Do you see, guys, how I got this negative 14? I mean 0.1401. Again, because my z is, so you have your z. It's our z is, in our example, was like negative 1.08. The position of the 10th digit is this one here. This is my 10th position. This is my 100th, right? So my nearest 10th would be this. So nearest 10th, nearest. So nearest 10th is the negative nearest 10th. That's negative 1.0. Now the 100th is, we said it's this 8 here. So it's 0.08. So the 100th, nearest 100th is 0.0. We have 8, right? So that's why here in the table, so in the first column, we went all the way down to negative 1.0, and then the value would correspond to the where your nearest hundredth is 0.08, right? So that's 0.1401. So let me just say, guys, here in this table, we have like, there are two pages in the table. So the first page, you have negative values of Z, right? Like here, your Z is like, it starts from negative 3.4, negative 3.3, negative 3.2, right? So all the way down to negative minus 0.0. So this first page is for negative values of Z. The next page, right? So we go to the next page of the table. Right here, you have the positive values of Z. Okay, so be careful. There is difference between the negative when your Z is negative and your Z is positive. Okay, so you get different, there are different answers. Okay, but the thing is, you always get like the area to the left of Z. So this table is supposed to give you the area to the left of Z. Always the left of Z, not the right. It doesn't give you the area to the right, only the area to the left of your Z. Okay, of course, here we are talking about this standard normal distribution where, you know, where the mean is 0 and sigma is 1. We'll see later in the next section. So if my mean is not 0, so what can we do to find, you know, our probability? But again, this is just for the standard normal distribution, right? When the mean is 0 and the standard deviation is 1. So all I'm saying,
That,
yeah.
I'm sorry to interrupt you.
Yeah,
That did not answer. How do we find the answer for the previous problem?
yeah, it doesn't answer. Yep, it doesn't answer. This is like this is a partial, like this is like the first step to the answer.
Okay.
Yeah, so the next section we're gonna try to find like a probability for any like normal distribution. Doesn't have to be the standard normal distribution. Yeah, next section we're gonna answer the question, but this is like the first step. First, we need this. We're gonna use this table as a first step, and then the second step we're gonna discuss the second step in the next section. Okay. But first, we need to know how to use this table for you, right? So, all right. So, all right. So let's have a couple of exercises. So the whole thing here, guys, what you need to know is, of course, how to use this table, and so we can have like the following. We're gonna have like 3 different cases. So, so there are 3 different cases. Okay. So in the first case, so case 1, this is when you want to find the area to the left. So Z is less some number. So case 1, this is probability that Z is less than some number. Let's say, I don't know, some number. So I'm gonna just take a random value here. Let's say 1.5. Okay, so this is Z less than 1.5. So as we said, less than, that's the area to the left. And to find the area to the left, all we have to do is just use the table. So here, just use the table, phi, to find this area to the left. Now, there is a second case, case 2.
Do you have to convert the number 1.5 into a negative?
Yeah, we're gonna do that later. Later, yeah, but yeah. No, actually, no. Like here, yeah, okay. Like in this example, let me just. So, like here in this example, your Z is 1.5. So what's the 1.5? So what's the nearest 10th? So the 10th position, of course, is you know, the first digit after decimal point. This one here.
5.
Yeah, it's just, well, yeah, just 1.5. Now, what's the nearest hundredth? Nearest hundredth?
100 is next to it.
Yeah,
So
next to
I'm
it.
assuming
So
0.
0, because when there is nothing, guys, it's just 0. It means it's 0. So here, there's nothing, but if there is nothing, then it's just 0. So the nearest hundredth is just 0.00. Okay, it's just 0. So now, if I want to use my table, I need to go to the Z 1.5 nearest hundredth, it's 0.00. So let's go to the table. So as I said, the first page is for negative Z. My Z is positive, right? Positive 1.5. So I need to go to the second page. And as you can see here, so the second page starts with Z 0.0, then there's like 0.1, there is 0.2, then we need to go to 1.5, right? And then my nearest hundredth, so we check the top, nearest hundredth, it's 0.00, right? So that would be the value next to 1.5, right? That's the 0.9332. You see the 0.9332?
Yes, I do. I
I
Right?
didn't know there was a second page. I just thought it was all negative.
Yeah, this is, yeah.
Yeah.
Second
Okay.
page is positive, yeah. So the answer, like the answer to this, to our example would be the 9332. So here, for example, the answer, so then the answer, oops. So then, yeah, so the answer here would be 0.9332. Anyway, so let me just, in 20 seconds, guys, let me just say, we're gonna do a lot of examples tomorrow, of course. Let me just say that the other cases when your Z is larger than 1.5. So in this case, this is Z larger or more than, larger than, and that would be the area to the right. So then the area to the right, it's not given by the table. We cannot find the area to the right by using the table. So what we do is, the thing is, the area to the right is always 1 minus the area to the left. So what we do is we find the area to the left using the table, and then I can subtract 1 from or this area to the left from 1, right? Then you get your answer, right? And then there's the third case, that's when Z is between two numbers. Like, let's say Z between, I don't know, let's say 1.02 and 1.58, for example. Just given a random example here. So this is the area between. This is the area between, So now it's not, of course, the area between two numbers is not given by the table. Area between 1.02 and 1.58. But the thing is, the area between two numbers is actually the area to the left of the larger number. So area to the left of the 1.58 minus, subtract the area to the left of 1.02. So of course I can get this area to the left from the table, and then I take the difference, and that will be the answer. All right. Anyway, I'm gonna stop here, guys, because I went over time. I'm gonna stop here, but tomorrow, of course, we're gonna do a lot of examples. We're gonna use our table, and then in the next section. So this is for the standard normal distribution when the mean is 0. Standard deviation is 1. But the next section, we'll see how to find like these probabilities for like a random, random mean and random standard deviation. All right, thank you for listening, guys, and hopefully I'm gonna see you tomorrow. Take care, everyone.
Take care.
Professor.
Thank you.
Bye.
Bye-bye.
Bye.
Bye. See you tomorrow.